Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 8E. My name is Amog Dhamdere, and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th edition of the International Congress on Information and Communication Technology, ICICT 2026. The 11th edition of this conference is being organized in hybrid mode. The physical event was held in London, and the virtual event is being held through Zoom from the 25th to the 27th of February 2026. I hope.
I think he dropped out. Can't hear anything.
Suggest to all the participants that all of you please stay connected with us until the closing remarks are given. If you have any queries or updates, then you can write it to me in the chat box. And just before we start, I would like to introduce our session chairs for this session today. Our first session chair is Dr. Swati Nikam. Dr. Swati Nikam is an associate professor of the Department of Artificial Intelligence and Data Science Engineering in Pimpri Chinchwad College of Engineering and Research, India. She has a total of 20 years of teaching experience in computer engineering. Her research areas are cyber physical systems, information security, and IoT. She has also published more than 30 research papers in reputed international journals and conferences. You're welcome, ma'am, and I request you to give us your opening remarks.
Hello, everyone. A very good evening, sir, and very good evening to all the participants. So this is a very wonderful opportunity of participation in this ICICT 2026. So I'm just eager to listen from all the budding researchers. So welcome you all and wish you all the best. Thank you.
Thank you so much, ma'am. I would now like to introduce our next session chair for this session. His name is Dr. Fuseini Inusa. I apologize for any mispronunciation, sir. Dr. Fuseini Inusa is a lecturer in the Department of Mathematics and ICT Education within the Faculty of Education at the University of Development Studies, UDS, in Tamale, Ghana. He is a professional teacher with nearly 2 decades of teaching experience. His research expertise spans computer science, artificial intelligence, data mining, and intelligent systems, with a strong focus on integrating advanced computing concepts into education and research. We welcome you, sir, and I request you to give us your opening remarks.
Hello, everybody. Can you hear me? Can you hear me?
Yes.
Yes, sir, you're perfectly audible.
Yes. Thank you so much. And I welcome everybody to this session. And we hope that the presentation will be very smooth so that participants will be able to give out the best in them so that we can enjoy the session. Thank you so much.
You're welcome, sir. Now we can move on to our first presentation for this session. Our first presenter is Darshana Khilwani from the AKS University in India, and the title of her paper is A Hybrid Approach for Cybersecurity Threat Detection Using Machine Learning and Pattern-Based Data Mining in Healthcare. Ma'am, I request you to kindly unmute yourself and start presenting.
Yeah, I'm sharing the screen. Should I share the screen?
Sure, ma'am. Just a second. You can go right ahead.
Yeah. Is my screen audible?
Yes, your screen is visible. You can start.
Yeah, so my topic is this, a hybrid approach for cybersecurity threat detection using machine learning and pattern-based data mining. These are the contents that I will be covering in the upcoming slides. As you all know, cyber attacks are growing more complex and harder. That rule-based systems are not able to detect the fraud, and we have to move ahead and to focus on the traditional methods. And so this approach is based on that only. We are like improving the system. Um, Machine learning and data mining help identify hidden or unusual behavior that rule-based systems often miss. So we are using the techniques like LSTM, assemble models, and explainable AI to improve the accuracy and trust in the system. Why a hybrid model? Because it reduces false positives and improves reliability, and it improves the accuracy and in the healthcare systems, and often machine learning provides fast and accurate detections. This is the diagram which shows the data using a random forest classifier, and then the detected anomalies are then validated using pattern mining, and the both the techniques are then fusion, and then we got the final detection output. These are the literature review that I covered. Proposed methodology is that the data set is cleaned, merged, and prepared to ensure accurate training and testing. The techniques like FP growth, a priori, and k-means used to uncover hidden or repeating attack behaviors. Then the results are merged through a meta decision layer and improving accuracy that reduces the false alarms and enhancing interpretability. These are the results and discussions. Let's see the table first. We have calculated the accuracy in the baseline model and the hybrid model. Baseline model was for a random forest only, and the hybrid model is for machine learning and pattern mining. The accuracy is improved in the hybrid model as compared to the baseline model, and also the precision recall and F1 score is also improved in the hybrid model.
Excuse me, ma'am, I'm sorry to interrupt, but there is a problem on your side. I think the slides of your presentation are not changing. So can you please check it once?
Yeah, sure. Now it is visible.
Yes, it is. You can continue.
Okay. So should I continue from the first, or should I like?
Anything. It's up to you.
Okay.
Actually, it would be better if you begin again.
Okay, from the first?
Yeah.
Okay.
Sorry to interrupt. You can
Yeah,
continue.
yeah. These are the contents. As you all know, cyber attacks are growing, and which rule-based systems are often not detect, and so we need to introduce the traditional methods. So I have like introduced a hybrid detection model that combines machine learning and pattern-based data mining. This is designed to function in real-time environments, enhancing both accuracy and response. And machine learning and data mining help identify hidden or unusual behavior that rule-based systems often miss. So techniques like LSTM, assemble models, and EAI improve both accuracy and trust in the system. Why a hybrid model? Because machine learning provides fast and accurate detection, reduces false positives, and improves reliability, and it also ensures accuracy in the healthcare systems. The diagram shows a hybrid security threat detection system where we have like taken the data set, which is pre-processed and analyzed using a random forest classifier to detect suspicious activity. The detected anomalies are then validated using a FP growth and a priori, and both outputs are combined to produce the final detection decision. These are the literature review that I have covered. And the proposed methodology includes the data set, which is cleaned, merged, and prepared to ensure accurate training and testing. FP growth a priori and k-means uncover hidden or repeating attack behaviors, which is like both results are merged then are through a meta decision layer, which improves the accuracy and reduce false alarms. These are the accuracy, and let's see the table first. In the baseline model, we have used the random forest, and in hybrid, we have used the machine learning and pattern-based data mining. We can easily see the accuracy is improving from the random forest to machine learning and pattern-based data mining. And similarly, precision recall and F1 score is also increasing in the hybrid models. This is the conclusion that this method performs well in the data set, reflecting real world scenarios, and it is suitable for healthcare networks where accuracy and transparency are essential. And in future, we are planning like evaluate on additional detection data sets and planning to test on multiple data set to have the more accuracy and precision recall everything. And these are the references. So if there are any questions.
Thank you for presenting, ma'am. I would now request our session chairs if they have any questions for our speaker.
Yes. Thank you, Darshana ma'am, for wonderful presentation. My question is like, what all algorithms you have chosen and how you've decided?
It is based on the machine learning and pattern based only, and it is decided based on the detection and fraud.
So how do you balance between the detection speed and accuracy?
It is like based on the formulas that I have introduced, and so we can like check from that how much accuracy we are getting and the precision.
Okay, ma'am. Thank you.
Dr. Inusa, any questions?
Yes, I have a question for you. Let's go to the metrics for measuring the efficiency of your algorithms. You did not consider AUC, ROC, area under the curve, ROC. May I know why you didn't consider that?
Because I am using different a priori and k-means, which gives better results in my research. So yeah, I haven't used the AUC and anything else for this research.
Okay, thank you.
Well, thank you for your presentation, ma'am. We can now move ahead to our next presentation for this technical session. So our next presenter is Anirudh Edupuganti. I sincerely apologize for the mispronunciation, from the Andhra University in India. And the title of his paper is Adaptive IoT AI-based Pest Control System with LLM Integration. So I request you to kindly unmute yourself and start presenting.
Yeah, I sent a request to share my screen.
Give me just a second, sir.
Yeah, I'm able to. Hello, everyone. I'm here to present Adaptive IoT AI Pest Control System with LLM integration for sustainable farming. This is Anirudh Edupuganti, and I did this under the guidance of Professor James Stephen. And this particular project is supported by Indian government. First of all, I would like to tell what is the critical problem that we found for the smallholder farmers. Annually, they lose 20 to 40% of their crop due to pests. That includes brown plant hopper, yellow stem borer, and rice leaf folder that devastate their yields directly threaten food security and income stability for smallholder families. So the current limitations are they rely on reactive, chemical intensive strategies that are environmentally unsustainable, health hazardous, and economical burdensome for some resource poor farmers. There's a huge technological gap for smallholder farmers to access the modern agricultural technologies because of their capital constraints. Where we have failed them is that existing solutions are designed for large-scale commercial farms requiring expensive infrastructure. There is no integrated end-to-end system combining real-time detection, environmental analysis, and automated non-chemical control for small farmers. So, in our literature review or critical research gaps that we went through are we saw an absence of end-to-end closed-loop systems that combine monitoring and autonomous control. Most solutions are fragmented, and there is a huge cost and complexity involved, and there is an information gap for the smallholders, farmers, to have their location specific on pest activity and weather-based management strategies. And there is also a huge non-chemical deterrent alternative uh, information gap to them. And current research prioritize optimizing pesticide application over replacing it. And there is a real world pilot implementation scarcity. Many systems would theoretically done or lab tested without field validation. And reliance on labor-intensive manual scouting of often fails to detect early infestation, leading to reactive calendar-based spraying. So we did this implementation study in Pendurti Mandalam, Visakhapatnam district, Andhra Pradesh, in in few villages with 15 plus volunteers and 1,000 plus farmers engaged with us. We documented the pest challenges and the cropping patterns from the farmers, and we captured particular constraints like power and night labor that is put in for a farming field. Our volunteers aided installation and calibration and troubleshooting. Farmers have started interacting with us and they became co-researchers in the system trails. We took this project in two phases, phase one and phase two. In phase one, we used a camera to take field images and we fed the data into YOLO V8 pest detection system and sent that to Grok LLM, which gave us initial recommendations. And in phase two, we took NPK and moisture and pH pest recommendation systems, then fed that data to YOLO V11 version. And then we used our local LLM that is trained on a regression model to get a final pesticide plan. Phase one is validating the core architecture by from using ESP32 image capture to YOLO V8 detection and LLM-driven recommendations. So our objective for phase one is that design and validate a low-cost prototype IoT AI pest detection system that integrates edge computing, deep learning, and LLM-based decision support for real-time pest monitoring in a resource-constrained environment. As I already told, we used ESP32 camera and Volo V8 and Grok LLM for our technological side. And for the field validation, we conducted in the villages that I showed earlier. And we measured critical metrics, including capture success and system performance through technical metrics and field outcome. The impact is to prove the advanced AI-driven pest management is viable without expensive non-infrastructure, and we established initial pest reduction at 26 to 35% so that we can scale up this research. Created a validated technical blueprint ready for transmission for the robust real-time deployment of phase two. So this is the concept of our phase one. And these are the core modules of our camera. It has a 32-bit dual core processor, and we have a good sensor, flash LED intensity, and it has a connectivity of Wi-Fi and Bluetooth. And this is an example of data what we get from uh, the YOLO model, and this we are sending it to the LLM. And these are the targeted class of the pests that we are detecting right now. And once we got the density and count and what type of pest, the grok is going to help us on understanding what type of pesticide we need and how many days we have to continue the monitoring. And post-analysis, we are also taking consideration of the environmental context. So we can the Grok LLM would let the farmer know the most possible reason of why that particular pest is infesting. In the phase two, we developed a system that requires minimal infrastructure with low technical expertise and internet connectivity for resource constraints for farming community. Here, our intention was to design integrated IoT AI architecture combining edge computing, YOLO 11 model, regression model, and LLM decision making. Enable real-time pest detection with weather-aware decision logic, implementing automated pest recommendation. We did in the same fields for the field validation, and the impact we are creating is that demonstrating and scaling the sustainability for smallholder communities, quantify the pest reduction and system reliability in real world, and we are aligned with sustainable development goals such as zero hunger, environmental sustainability, and rural livelihood development. This is our base architecture. We are using Raspberry Pi 5 and thermal cams and soil sensors. Our soil sensors can detect potassium, nitrogen, and phosphorus. And that data is fed into YOLO 11 AI that can continuously does pest detection and counts the density, and that is then sent to the data is pushed into our local LLM for validation. And once that validation and everything is done, it is going to give us a pesticide plan. These recommendations are validated by the farmers themselves. So this is our in-depth architecture. So we are using YOLO V8 as a backbone for our initial input prediction. And the confidence threshold is set to be more than 0.5, or else we ignore, and then we validate on what type of species based on our target species that I showed before. And non-maximum suppression redundant overlapping boxes are removed to ensure single detection per pest. So this is what happens in detail, and we managed to get a 91 to 33% mean average precision. And our GPU inference time is 200 millisecond, and we are targeting 4 species. And each year we took 10K training images to detect each pest. These are the technical modular hardware, what we used. And for advanced detection and analysis, this is what we did. Visual data of high resolution RGB images, nighttime heat signatures, and soil NPK, pH, moisture levels are also taken into consideration. And our technological aspect, AI processing core, is going to give us a structured output.
Excuse me, sir.
Yeah.
I'm sorry to interrupt, but you have 2 minutes of presentation time left. Thank you.
Yeah, sure. And the technical performance metrics is 91%. We got a capture success. and communication reliability is 91% and 95% and 91% of accurate detection, and we got accuracy of 99%. These are the results. We got a high reduction rate of 32 to 35% for BP and YSB, and a slightly lower reduction percent of 26 to 30% of RLF and RGM. Overall, we got 31% of reduction across all pilot sites. We detected a total of 1,600. This is under mean confidence of 0.92. Yeah. And this is our total end-to-end performance breakdown. And this is our participatory engagement of 1,000 plus farmers, and we did the whole project for 12 weeks of continuous monitoring and 2 units per village in real time. Dual validation decision system is we used a regression model, cross-checking, and then local LLM for a quantitative context. And this is how the output is and what ingredient we need to use for that particular pest. Our future infrastructure to develop is that we want to have an off-grid power system, AGI and scaling and modular accuracy, and create an application for farmers and impact studies for multi-season analysis of yielding pest. The conclusion is this research is successfully demonstrated the feasibility and effectiveness of an integrated IoT AI pest detection and adaptive control system, proving that advanced precision agriculture is viable for resource constraint of smallholders. If agriculture fails, everything will fail. This is Anirudh. Thank you. If there are any
Thank
questions,
you.
I'm happy to take.
Yeah, thank you for your presentation, sir. I now request our session chairs if they have any questions for him.
Thank you, Mr. Anirudh, for presentation. I have one question. To what extent does this minimizes pesticide usage, and what about the cost while improving on the yield, overall yield better?
So right now, the cost reduction is 20 to 50% according to the type of farm. If it is a rice paddy field, we were able to get it to 30% down, not use a chemical pesticide. And the future plan is to use sound and lighting so that we can make sure we are getting rid of the pests.
Okay. And do you find any challenge in the adoption?
Actually, the farmers are very helpful. Yeah, the farmers were, when we started talking with the farmers, they are really helpful because it's a problem that we are solving that they have. All 1,000 farmers actually, they started taking pictures and sending us for our own image training. What type of pests?
Okay. Thank you. Wonderful research.
Dr. Inusa, any questions?
Okay. Thank you. This is for small-scale farmers. Am I right?
Yes.
Hello?
Yeah,
Can you hear me?
sir. Yes, sir.
You're audible, sir.
Yes, it is for small-scale farmers.
Correct. Yes,
Can
sir.
they get the resources to run the system? Do they have the
Sir, your
resources
voice is
to
cracking.
run the system?
Pardon your voice, bro. Can you repeat the question, please, sir?
Can the small-scale farmers get the needed resources to run the system? Sorry.
Yes, we are creating device so that they can just put it on the field 1 meter above the crop yield, and they would be able to get a WhatsApp message to their phone on how many number of pests and what type of pests that they're finding in the field. It's a very cost-effective thing too.
Okay, thank you.
Okay, thank you for your presentation, sir.
Thank you. Thanks for the opportunity.
Yes. We can now move on to our next speaker. So our next speaker is Tim Peters from the Stuttgart Media University in Germany. And the title of his paper is Design and Prototypical Evaluation of a Multi-Agent, Multi-Model Workflow for AI-Driven Web Development. So I request you to kindly unmute yourself and start presenting.
Yes. Okay, hello everyone. My name is Tim Peters and I am pleased to present our paper, which is based on my master thesis, which I finished last year at the Media University in Stuttgart. In this short presentation, I'll introduce the motivation behind the work, the proposed concept and architecture of the workflow, as well as the evaluation method and its key results. In the recent years, generative AI is rapidly transforming various industries, such as software and also web development. For example, LLMs are capable of generating code or test cases, while image models support creating UI layouts and visual prototypes. However, their usage is currently fragmented, and they mostly operate as isolated tools without a structured coordination, role specialization, or shared project context, and end-to-end front-end automation remains still limited. And yeah, the current trending approach of AI agents and their connection in so-called multi-agent systems show promising potential. However, most of the current research focuses on back-end logic or general code generation, and whole end-to-end front-end workflows were currently underexplored. My work, therefore, examines the potential of MAS-based workflows for automating key steps in front-end development. And in my paper, I focused on these two research questions, which you can see on my slide here. Yeah, before moving to multi-agent systems, let us briefly look at what defines an AI agent in the first place. They are LLM-based systems with goal-directed behavior and can use tools or memory to act beyond text generation or simple prompt responses, so they can operate autonomously to solve structured and complex tasks. They can also communicate and coordinate with other agents, and when multiple agents collaborate toward a shared objective, this is referred as so-called multi-agent system. To simplify the development and implementation of such MAS, there are various frameworks. I think, yeah, like now every week or month popping some new frameworks up, which are trending. Yeah, and they just provide like a basic architecture for implementing such workflows. And for my prototype implementation, I choose the Crew AI framework. It allows structured agent roles and clearly defined tasks, ideal for modeling a web development workflow. The central unit in the Crew AI is the crew, which consists of multiple specialized agents. The agents can use tools or memory or external resources to perform their tasks. The task itself are assigned to a specific agent and executed in a controlled sequence. The framework also supports delegation and iterative refinement between these agents. The workflow design is guided by fundamental principles of both software development lifecycle and user-centered design principle, ensuring that technical and user-centered aspects are considered. As well, some other concepts I implemented in my workflow were from my literature research, from other papers and approaches you could find in my paper. The workflow is structured into 4 main phases, which you can see here in this graphic. requirements, design, implementation, and quality assurance aligned with established development principles. The architecture also follows a modular role-based structure, and the core agents are modeled after roles which can be typically found in real-world development teams. Each phase also produces intermediate results, and finally, validation agents introduce a structured feedback mechanism to ensure quality and enable iterative refinement. The primary agents in the workflow are all powered by GPT, or like GPT-4 or 4o, and for validation task, we use the Gemini different model to provide cross-model feedback and reducing model-specific bias. Here you can see also an overview of the output artifacts in each individual phase. The Next.js page with the components and styling is, of course, the central part of the workflow. In this presentation, I won't go into any low-level implementation details, but here you can see as an example an agent definition, which is typically written in the YAML format. As you can see here on the screenshot, each agent definition includes a clearly defined role, a specific goal, and the backstory, which helps to shape the agent's behavior. To address several challenges that emerged during implementation, the use of tools I mentioned earlier was essential here. We differentiate between built-in tools that are provided by the Crew AI framework, such as the file reading or writing utilities, and also some custom tools that were specifically developed for particular edge cases. For example, one custom tool was implemented to render structure wireframe images out of text description by the former agent. The workflow was evaluated using the dashboard application of a startup, Farah AI, as a reference system. The application was built with Next.js and SCSS, and its project structure was directly integrated into the Crew AI environment. A style guide and a machine-readable API documentation were provided as contextual knowledge for the agents. For the workflow, I selected 3 representative subpages for a reconstruction by using the workflow. The first one was a static about page to test fundamental layouts and structure generation. The second one was a dynamic reports page, which introduced reusable and interactive components with also backend integration. And the third use case was a login page, which combined form interaction, error handling, authentication logic, and also generated visual asset. My evaluation followed a multidimensional approach combining technical and perceptual metrics. The code quality was assessed using SonarQube, focusing on maintainability, technical depth, and structural complexity. And cyclomatic and cognitive complexity were used to measure logical structure and readability. The visual similarity between the benchmark screen and the workflow generated UI was measured by using the LPIPS, which is basically a deep learning based perceptual metric which tries to imitate the human vision. Also, for user perceived aesthetics, I used the vis-a-vis questionnaire, which assesses UI aesthetics within 4 different categories with a Likert scale. And this combination of metrics allows assessment of both code quality and also user experience. While the detailed metric values for each use cases can also be found in the paper, I will now highlight the most important results and move forward toward a broader discussion of the system's performance. In summary, the evaluation shows that structured multi-agent workflow can reliably generate functional front-end components across different complexity levels. All generated implementations achieved solid maintainability ratings, indicating a good structural quality. In lower complexity scenarios, the system performed comparably and in some aspects even better than the human benchmark. And yeah, the internal validation and feedback loops improved robustness and reduced obvious structural errors. However, runtime fragility remained still a challenge, particularly with file paths, imports, or framework-specific conventions. The visual quality was generally acceptable, but vis-a-vis results showed nuanced design aspects such as craftsmanship or layout refinement were weaker than the benchmark in complex cases. Also, the system showed limitations in handling edge cases and detailed interaction logic. Furthermore, the workflow heavily depends on well-structured and detailed input prompts, and it showed that under specific requirements can degrade the output quality. And also, due to the non-deterministic character of LLMs, the reproducibility remains a challenge, and outputs may vary between executions, even with the exact same input prompts. Finally, what does these findings mean in practice? You can say that such systems can accelerate early stage development by generating structured layouts and reusable components. And the modular architecture also allows integration of additional validation mechanisms such as accessibility or search engine optimization checks. The workflow can also reduce repetitive tasks and free developers to focus on higher level refinement. While full autonomy isn't yet achievable, structured multi-agent orchestration represents still a promising blueprint for the future of AI-supported software engineering workflows. A possible next step could be that, like improving robustness and reliability by reducing output variability through better coordination and better strategies, and maybe also structured human-in-the-loop feedback. At the same time, future research could also explore extended tool chains, parallel agent teams, or deeper analysis of the influence of different LLM models and frameworks. For example, the currently trending OpenClaw or anti-gravity. Then, thank you for listening to my presentation. And if you have questions, you could ask. Thank you.
Thank you for your presentation, sir. I request our session chairs if they have any questions for Tim.
Yes, thank you, Mr. Tim, for your presentation. I have one question, like how foolproof it would be against the error propagation across the pipelines?
Could you please repeat again?
This work, how foolproof it would be against error propagation across the pipeline, because you are having multi-agent workflow.
You mean like against a single agent or like human work?
I mean, you can comment on both.
I think against like a single agent, it would be much more efficient, especially like in focusing on like single specialized tasks, for example, like just generate code and then generate a design or test the code and so on. That's the big advantage of having like a multi-agent workflow compared to like only one LLM. There are also, in my literature research, I found some papers which also showed this, that it improves the quality a lot when like an LLM or a single agent can really be prompted or focused on one specific task. And in comparison to like a human team, it's hard to compare, as right now I would say it's just at a stage or like at a stage of supporting human teams instead of like being capable of fully replacing them.
Have you considered any of this in your work? Have you?
Yeah, I definitely consider this, like in my practical implementations, for example, for like early stage prototyping or just getting a rough prototype application out of an idea or testing something out. This is definitely something I use, and also I'm trying to use it for like task like documentation or commenting code and stuff like that. So I moved a bit away from like end-to-end front-end development, but using it as assistant for like such tasks which are a bit don't call them annoying as it has to be done, but to support such tasks which lay a bit out of the topic of coding or design.
That's fine. Yeah. Thank you.
Thank you.
Dr. Inusa, any questions for our speaker?
Yes, I have a question for him. Thank you for this wonderful presentation. As part of your discussions, you said when the user interface gets complex, performance reduces. So does it mean that it supports unimodal interfaces than multimodal interfaces?
What I meant with that was that when there are more visual components like images, icons, and stuff on the interface, for example, at the login page, the performance at the vis-a-vis questionnaire, which I handed to like 20 participants, went a bit down compared like to the static or like to the simpler page where there were only text. And there you could see that even if the performance wasn't bad, it couldn't really reach the quality of like an human-made design or layout.
Okay, so as we advance, user interfaces become more complex. So with this challenge, how will one incorporate audio-based and sensor-based interactions in the interface?
So you mean, or could you repeat the question again? Sorry.
What I'm saying is, as we are advancing in technology, user interface becomes more complex. So with this challenge in your research, how do we incorporate sensor-based and then audio-based interactions in the user interface? Wouldn't that affect the performance as you indicated?
Yeah, I can imagine that it will affect the performance, and maybe more like also human feedback at specific stages of the workflow could be helpful. Or for example, right now I just wanted to try like an end-to-end web workflow, but it could also be like a possibility that maybe some designer or something uses a wireframe or like a production ready to design as an input, which then maybe could be recreated or something. Maybe this could be a possible extension, or maybe right now there are also like popping up in the last couple of months some really good Gen AI tools for such design stuff, but they don't really have an API for that to integrate in the workflow. Maybe if they have in future, this could also be a possibility for like more complex designs with a lot of components in the user interface.
Okay, thank you.
Thank you.
Thank you so much for your presentation, sir.
Thank you.
We now move on ahead with our next presenter. Our next presenter is Nadia Putri from the Binus University in Indonesia. And the title of the research paper is Designing Interpretable and Energy Efficient AI Pipelines for Sustainability Analytics, a Proof of Concept Framework. Ma'am, I request you to kindly unmute yourself and start presenting.
Hello, I am Nadia and I will represent my team as today's presenter on our research titled Designing Interpretable and Energy Efficient AI Pipelines for Sustainability Analytics. So, why this research matters? ESG reporting today is complex, fragmented, and difficult to interpret. At the same time, many AI models used in ESG analytics are black boxes and energy intensive. So this creates a paradox that unsustainable AI is being used to measure sustainability. So our key idea is to position machine learning as a translator, not a fortune teller. Instead of predicting ESG scores, we ask, can AI help humans understand ESG data responsibly and efficiently? So, what makes this framework different? Unlike typical ESG AI that focuses on black box accuracy, our framework prioritizes transparency, governance alignment, and energy efficiency, with explainability embedded from the start. Our goal is to design a proof of concept ESG analytics framework that starts from reporting standards such as GRI, SASB, TCFD, and others. Also applies lightweight machine learning, follows green computing principles, and focuses on understanding rather than prediction. Conceptually, our framework views ESG analytics as an organizational capability. It also integrates governance theory, business intelligence, and computational sustainability through the greener. Practically, our system organizes ESG disclosures into a governance aligned structure, and it also creates interpretable ESG scores and explores relationship between emissions, financial performance, and governance disclosures. How we structure our ESG layer. In the first layer, ESG indicators are standardized based on global frameworks. So this step does not produce a final ESG score, but prepares the data for meaningful interpretive analysis. And our framework enables pillar-level understanding, showing how environmental and governance indicators evolve over time and supporting managerial and governance interpretation. We use lightweight models such as XGBoost and also ELM as our interpretive tools. They are applied to explore relationships, not to generate predictive ESG ratings. Our design has explainability by design. So explainable AI using SHAP as our core component of our system. It shows why specific indicators matter, supporting transparency, traceability, and also accountability. And by using simpler models and fewer iterations, the framework reduces energy consumption and computational waste, aligning AI design with sustainability values. Our research contributes methodologically by demonstrating interpretive ESG analytics, and practically by offering a replicable framework for emerging markets, and also conceptually by reframing ESG analytics as governance-oriented system design. But for our limitation is that this study is a proof of concept with a small dataset and a non-predictive focus. So future research can expand to multi-firm data, also alternative explainability methods and trade-off analysis between accuracy, interpretability, and also energy use. In conclusion, sustainability is not only about what we measure, but also about how we measure it. Thank you for your attention.
Thank you for your presentation, ma'am. I request our session chairs if they have any questions for you.
Thank you, ma'am, for your presentation. So my question is like, what would be the practical challenges in this? Can you foresee any?
For the practical challenges, so our design that I told you is for now only a proof of concept. It's just a design, a framework. It hasn't been applied to a big data, so maybe it will need some adjustment in the framework.
Okay, thank you.
Thank you for your question.
Dr. Inusa, any questions for our speaker?
Yes. Thank you for the presentation. Can this be used by an average user? Is it for the average?
Yes, this is for the average user. We use AI to also help us generate the code, and also to help us find what data we need to use for our framework. So it's possible for the public or general to use.
Okay, thank you.
Thank you for your question.
Thank you for your presentation, ma'am. We will now be moving on to our next speaker. So our next speaker is Martina Jukic from the Virovitica University of Applied Sciences in Croatia. And the title of the paper is Distorted Perceptions of Women in Professional Communication and the Role of Gender in Speech Interpretation. Ma'am, I request you to kindly unmute yourself and start presenting.
Thank you. Could you just please tell me, can you see my presentation?
Yes, your presentation is visible and you are audible as well, so you can start.
Okay, thank you very much. Hello everyone, I am sending you sunny greetings from Croatia, finally sunny. My name is Martina Jukic and I am also from the University of North too. And I will represent you this topic that I made with my professor Ana Globočnik-Žunac and Vesna Sesar. I will first tell you something about theory, about this communication. I will show you our research methodology. I will show you our results. And of course, I will end this with discussion and conclusion. When it comes to professional communication, I believe that everyone wants to be equal. However, women are still often judged based on their voices, their appearance, or just their authority. Why we chose this subject is because we saw these headlines that are still telling us that we have a problem, and I believe in everyday communication we can also see problems when it comes to professional communication. Of course, every presentation needs to have a little bit of theory, but don't worry, I won't overwhelm you with theory, but I would like to make some few key points. When it comes to professional communication, it is important to say that professional communication is something that is constructed by and shaped by individual biases, organizational cultures, and power relations. That also we have thing where the one who is receiving the message, he is the one who is giving the meaning of it. That we have differences between women and men, how they communicate. And when it comes to communication accommodation theory, that theory is telling us how we adjust our verbal or non-verbal behavior to be accepted in socialization. According to some researchers, women are the ones who will talk more about private topics, and they will have more relation ways and emotional ways to tell something, while men will be focused on the more topics that are general public, and they will be more direct. Also, women will use words such as we, are, while men will use something that is I and my. Some researchers suggest that when you are searching something between women and men communication, you are searching something between two cultures. This is also interesting that women will also in their everyday communications have statements that will have question marks in it. Something as, it's a nice day, isn't it? They will use that because they want to feel acceptance in their statements, and that's something that people will usually misjudge and think that is lack of authority. It is important to say that communication is not shaped only from biology, but also from socialization and from early childhood. When it comes to research methodology, we had a quantitative cross-section survey that we had online. These are the main research questions. I won't read them all right now, but you will see and hear what I will tell you what we actually got. These are the hypotheses of the study that we had. We had 4 hypotheses. The first one is telling us there is statistically significant difference between women and men in the perception of verbal communication characteristics in professional context influenced by gender-based stereotypes. Second hypothesis is there is a difference between women and men in the perception that authority in professional communication is more frequently attributed to men than to women. Third hypothesis is women and men differ in the level of adaptation of verbal and non-verbal communication styles in professional settings to avoid negative reactions or stereotypical evaluation. And the fourth one is women and men differ in the frequency of experiencing communicative discouragement in professional environments. This was made in Croatia, so I will tell you everything that has thing in Croatia. It's not national. We had 196 women in this survey, participants, and 180 men. You can also see the level of education they had. Mostly we have people that have high school or they have graduated degree. You can also see the years of experience. From 0 to 5 to 6 to 12, we have mostly people that have 0 to 5 years of experience. And you can also see generation they are. And we have the most people in millennials generation. These are the sectors in Croatia you can work in. This is very important because we wanted to see in these sectors where do we have problem when it comes to stereotypes in professional communication. All data was analyzed with SPSS with appropriate statistical measures and tests of significance. When it comes to statistics, don't worry, I won't bother you with every single detail, but I will definitely tell you something that is the most important. And if you want to know more about this, you can read that later in our paperwork. What we got is that we can confirm 3 hypotheses. That means that women perceive gender-based stereotypes more frequent than men. Authority is still more often attributed to men, and that women will adopt more their communication style and they have experienced interruption more often. When it comes to the 4th hypothesis, we could partially confirm that because women reported they do experience it, they do have interruption when they speak, but we cannot say that rejection was until repaired by a person of the opposite sex. When it comes to when a woman expresses her opinion assertively, we got something that is quite interesting, and that's that a woman will perceive assertive communication as confidence, while men will see assertive women as aggressive. When it comes to difference in the perception of gender conditioned communication stereotypes by a sector, we got results that professional communication is the biggest problem in healthcare and social work and education, and in healthcare and social work. That's the places where we have the biggest problem with stereotypes according to women communication. And women communication is the least stereotyped in IT sector, energy sectors, and in construction sectors. So that means that we have to research more why things like this are happening in healthcare and in education sectors and in public administration sectors too. When it comes to discussion and conclusion, as you could hear what I said, women are frequently recognized, they are recognizing stereotypes, that authority is still something that is attributed to men, and they will adopt their communication style, that assertive women are more negatively interrupted by men, that the most pronounced stereotypes are in healthcare, public administration, education, and the least evident is in IT, construction, and energy sectors. One important thing I have to say is that this study focuses on perception and something that people experienced. This is not something that we can talk that is objective for whole Croatia, but it's definitely something that people experienced, and it demonstrates how gender biases are actually doing a thing in professional context. Overall findings are telling us that there is need to see what is the problem in these professional communication practices, then we need to focus in those sectors where we have problems. And for the end, one thing that I believe you all heard in your life a lot of times, think before you speak. Why is this important? Because words have meaning, and we must be careful with what are we saying to the others, and of course, what are we saying to ourselves. I would like to thank you to everyone for your attention. If you have any further questions, you can contact us, and it is a pleasure to be part of this conference, and thank you very much one more time.
Thank you for your presentation, ma'am. I now request our session chairs if they have any questions for our speaker.
Yes, thank you, ma'am, for your wonderful presentation. My question is like, can you highlight which of the linguistic features of woman's speech, would create that biased interpretation in workplace? Is there any study or your observation?
You mean what I think in linguistics is the problem when it comes to that, or?
Sorry?
Sorry, could you repeat the question?
Yeah, I mean, can you tell me maybe from study or from your observation, like what are linguistic features, in the woman's speech, they create that biased interpretation in workplace?
I believe the biggest problem we have is that, as I said, women tend to use question mark statements where you want to other people to accept the thing you want to say. I think that's the biggest problem because, as I said, men are more direct and they will tell their opinion about it, and women want to seek confirmation, I believe.
But is there any backup or findings from research, or how do you support this statement?
It's not our statement, it's a lack of made that research that will use words as it's a nice weather, isn't it? That's why I'm saying it.
But I mean, is it the generic observation or
sorry?
Or is this the generic observation or maybe in the age group or as per the location area? I mean, is there any other parameters or factors which will categorize?
Could you please write the question? I have distortion and I can't hear you properly. So
Hello, is my voice audible?
Yes, you're audible, perfectly audible.
Okay.
I have posted the question in chat.
Yes. Okay, it's a generic study. Yes, we had this study. Okay, so we made a survey that we published online, and we gave people to tell us more about their perception. This is not something that we can tell is objective, and it does happen with certain measurements, but this is more something that people believe that that's happening to them.
Okay, fine. Thank you.
You're welcome.
Dr. Inusa, any questions?
Yes.
Sure.
The presentation is very interesting, but I have 2 questions to ask. Did you consider tone as part of the elements of speech to determine these findings?
To determine
Tone
what?
in speech. Tone.
Tone and
Did
speech.
you consider
Okay.
tone? Yes.
Yes. In our survey, we didn't talk about tone. There was not question about tone, but we did have questions about how women decide to have more direct communication or not. So tone was not one of the questions.
What about attentiveness? Attentiveness. Did you consider attentiveness?
I'm sorry, could you please repeat, or I have a problem with
How
distortion.
How they pay attention?
He means to ask if you considered attentiveness as a factor.
In what way attentiveness?
In speech.
We did not, but I think that's a very nice thing that we can maybe do in further research. I will write that. I think that's something that we can use in the future. Thank you.
Yes, because for effective communication, there should be attentiveness. You should pay attention. Yes. Thank you so much.
Yes. Thank you.
Okay, thank you, ma'am, for presenting. We now move on to the last presentation for this technical session, which will be done by Alketa Haiso from the Ismail Kemali University in Albania. And the title of the research paper is Monthly Inflation Forecasting in Albania, a comparative study of econometric and machine learning models. Ma'am, I request you to kindly unmute yourself and start presenting.
Yes. No. It's okay? I don't know.
Your voice is audible, ma'am.
Yeah. Do you see?
No, we do not see your screen yet.
Entire screen. I don't know why. Share. Okay, I think it's okay now.
Yes, your screen is visible. You can start.
Do you see the presentation? Do you see the presentation here? Yes, I think it's okay. I am Alketa Huso from the University Ismail Cemali, Albania. Today I will present our study on monthly inflation forecasting in Albania, where we compare traditional econometric models with machine learning methods. Inflation plays a central role in monetary policy and economic decision-making. In small open economies like Albania, inflation dynamics are often influenced by external shocks, exchange rate movements, and global price fluctuations. At the same time, Albanian inflation shows strong seasonal patterns, especially at the monthly level. For policymakers, having accurate short-term inflation forecast is essential in order to design timely and effective policy responses. Given these challenges, our study focuses on two main research questions. First, can machine learning models outperform traditional seasonal econometric models in forecasting monthly inflation in Albania? Second, even if machine learning improves accuracy, can it remain interpretable and economically meaningful? Our goal is therefore not only to improve forecasting performance, but also to ensure that the model remains explainable, consistent with economic intuition. For our empirical analysis is based on official data published by the Albanian Institute of Statistics. We use monthly consumer price index data covering the period from January 2017 to August 2025. The frequency of the data is monthly, which allows us to focus on short-term inflation dynamics. The target variable in our study is month-over-month percentage change in the total consumer price index. The Consumer Price Index, or CPI, measures the average change in prices of goods and services consumed by households. It is constructed using a weighted basket of products, including food, transportation, housing, health, and other categories. Each category has a specific weight based on its importance in household consumption. Inflation is then calculated as the percentage change in this index over time. In this slide, we examine the behavior of monthly inflation over time. The series shows clear volatility with frequent fluctuations between positive and negative values. We also observe visible seasonal patterns, particularly recurring movements around similar months each year. These characteristics indicate that inflation in Albania is not purely linear or stable over time. It is seasonal and subject to short-term regime changes. This motivates the need for flexible forecasting models that can capture nonlinear dynamics. To answer our research questions, we compare 4 different forecasting approaches. First, we use a naive model, which simply assumes the next month inflation will be equal to the most recent observed value. Second, we use a seasonal naive model, which assumes that inflation will repeat the value from the same month of the previous year. These two models serve as a benchmark references. Third, we estimate a seasonal econometric model, specifically a SARIMAX specification, which captures autoregressive dynamics and annual seasonality. Finally, we implemented XGBoost, a machine learning model based on gradient-boosted decision trees designed to capture nonlinear relationships and regime changes. By comparing these models, we aim to evaluate whether machine learning provides measurable improvements over traditional seasonal econometric approaches. It is so why XGBoost? Because it is based on sequentially built decision trees where each tree corrects the errors made by the previous one. This allows the model to capture nonlinear relationships and threshold effects that may not be adequately modeled by linear specifications. Importantly, XGBoost includes regularization mechanisms that help prevent overfitting and improve out-of-sample performance. The evaluation strategy. When working with time series data, we cannot randomly split the data set into training and then testing samples. Instead, we apply rolling origin one-step ahead validation. So we begin by training the model using an initial window of 36 months, 3 years. Then we forecast the next month only. After that, we expand the training window but by 1 month and generate the next one step ahead forecast. We repeat this process sequentially until the end of the sample. This approach closely mimics real-world forecasting conditions. The results. As a first step, we evaluate two simple benchmark models. The naive model assumes that next month inflation will be equal to the most recent observed value. This model performs relatively purely, with higher May and RMSE values indicating that it fails to capture important dynamics in monthly inflation. In contrast, the seasonal naive model assumes that inflation will repeat the value observed in the same month of the previous year. This model performs significantly better than the simple naive approach. The improvement in accuracy confirms that annual persistence plays a dominant role in Albanian monthly inflation. In other words, seasonality is a key structural feature of the data. Next, we evaluate the seasonal econometric benchmark, specifically the Sorimax model. The estimated seasonal autoregressive coefficient is 0.894, which is very high. This confirms that annual persistence plays a dominant role in Albanian monthly inflation. In other words, inflation in a given month is strongly related to inflation in the same month of the previous year. The model successfully captured this annual seasonal structure. However, we also observe that Sorimax tends to smooth short-term fluctuations. While it tracks the general seasonal pattern well, it does not fully capture sudden changes or short-term volatility. We now turn to the machine learning model XGBoost. In terms of forecasting accuracy, XGBoost achieves the lowest mean absolute error, meaning among all models. This indicates that, on average, its predictions are closer to the observed inflation values. Beyond the numerical improvement, we also observe that XGBoost tracks turning points more effectively. It responds more quickly to increases and decreases in monthly inflation, especially during periods of higher volatility. This suggests that the model is more adaptive to short-term changes and regime shifts. Although XGBoost improves forecasting accuracy, interpretability remains essential in a policy context. To address this, we apply sharp analysis to decompose the model's predictions. The results show that 12-month lag of inflation is the most influential predictor. This confirms once again the strong annual persistence observed earlier in the econometric analysis. In addition, short-term volatility measures the recent inflation dynamics also play an important role. These findings are economically coherent. They indicate that the machine learning model captures both seasonal persistence and short-term fluctuations in a meaningful way. To conclude, our study shows four main results. First, inflation in Albania clearly follows a seasonal pattern. Prices in a given month are strongly related to the prices in the same month of the previous year. At the same time, inflation is not stable. It changes over time and can be volatile. Second, even a simple seasonal model performs quite well. This confirms that seasonality is very important in explaining inflation. Third, the XGBoost model improves short-term forecasting accuracy. It predicts monthly changes more precisely and reacts better to turning points. Finally, the model remains interpretable. Using sharp analysis, we see that seasonal effects and recent price movements are the main drivers of predictions. In summary, machine learning can improve short-term inflation forecasts while still providing clear and economically meaningful explanations. Limitations and future work. This study has some limitations. First, the model is based only on past CPI values and their patterns. We do not include other economic variables that may influence inflation. In future research, we plan to include factors such as the exchange rate, energy prices, possibly global inflation indicators. These variables could help the model better capture external shocks and improve forecasting accuracy. Machine learning can help improve short-term inflation forecasts while still keeping the model understandable. Thank you very much for the attention.
Thank you for your presentation, ma'am. I request our session chairs if they have any questions for our speaker.
Yeah, I have one question. Like, what all external parameters would impact the most in this prediction accuracy?
Yes, external parameters, especially those that create instability in economy, will bring a lower accuracy in every model, not in only XGBoost model, but every artificial intelligence model, every intelligent models with the first high shocks. Yes, we'll have a lower accuracy, but if the data are collecting and the times went, yes, the model capture the behavior of the economy. So for this reason, these kind of models, intelligent models, aren't using alone in defining the inflation and the other econometric parameter. Classical economic theory are applying yet combining with intelligent models, because they are related more from the behavior. Intelligent models are depending from the data, and the classical theory are depending from the behavior. So they are combining together. But yes, external variables wanted that we to add input variables, more input variables, yes. But XGBoost, it's a good model and for these kinds of variables, yes.
Okay. Thank you. Thank you.
Thank you. Thank you.
Dr. Inusa, any questions for our speaker?
Yes, please. Thank you for the presentation. The machine learning algorithm prediction you did, may I know the metrics that you use to measure the efficiency?
Yes, only, yes. To measure the efficiency, I used May, absolute error, and RMSA, which gives only numerical values only for test of data. But we know that to measure the efficiency of a model, it is not enough to measure only one test, to measure this kind of errors only in one test. So we did another experiment, rolling origin validation. With rolling origin validation, we take 36 months as training and then find only the next month and predict the next month. And after that, all this is using as training, and then we predict the other month, and then we did these experiments window after window, and we saw that this kind of errors were lower. With XGBoost, they were lower than any other models. This tells us that according to in the nature, where we know until now, and we have to define what will happen the next month, in the same way, this kind of experiment is near the practice, and it goes very well with XGBoost. It brings the lowest errors.
Okay.
Yes. Because the robustness,
Thank you so much.
Model is, yes, thank you very much. Thank you.
Thank you for your presentation, ma'am.
Thank you.
Well, that brings us to the end of our session. I now request our session chair, Dr. Swati Nikam, for her closing remarks. Hello, ma'am. Am I audible?
Yes.
Am I audible, sir?
Yes, ma'am, you can speak.
Yeah. So very good evening to one and all. And it was very nice to hear from all of you, based on your meaningful discussions, innovative ideas. It was quite enriching for us also. So thank you very much for sharing your research, budding research. So keep doing the research and wish you all the best for your future research endeavors. Thank you. Thank you, one and all.
Thank you so much, ma'am. I now request our session chair, Dr. Husseini Inusa, for his closing remarks. Hello, sir. Am I audible?
Can you hear me?
Yes, sir. You can speak.
Okay. Thank you so much. I think we had a very wonderful session, and all participants have been able to demonstrate good knowledge of the content they shared with us. I want to thank everybody, and it is my hope that we'll meet again in the near future. Thank you.
Thank you so much, sir. I sincerely thank all of our authors for their excellent presentations and contributions in this session, and also all of our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of the entire team of ICICT, thank you for your support during this 11th version, and we will be more than happy to have all of you for the 12th version in 2027 as well. A quick announcement for all the presenters. You would be getting your digital certificates via email within 2 working days, and the publications will be live within 7 to 8 months. So kindly cooperate with the team of ICICT. I would also like to thank our session chairs once again for chairing this session. And this is just a small token of appreciation on behalf of Team ICICT 2026. Thank you for your valuable presence. Just a small request for everyone. Kindly switch on your cameras for a quick snapshot of this virtual conference. Just a second. Yes, we are done. So yeah, thank you everyone. Stay safe and take care.
Thank you. Bye.
Thank you. Bye-bye.